Hey everybody, my name is Caleb Carlton and I'm a master's student in environmental geosciences, and I'm going to take you through my block diagram here real quick. So looking at my diagram, got a lot going on, but my oldest layer is down here, some coarse grained sandstone, moving into some shale, moving into some limestone, and these layers, oldest moving to younger, informed by the law of superposition, stating that sedimentary layers are deposited horizontally on top of one another from oldest to youngest towards the top. After that, I'm moving, also I should mention that we're fining upwards here in these layers, indicating a marine transgression taking place at that time. After that, we have an angular unconformity happening here. We have folding into a syncline formation of these layers. And that's informed by the principle of original horizontality, stating that sedimentary layers are deposited horizontally parallel to the surface, and that some event has occurred to change these layers from their original horizontal orientation. After that, we're looking at number 5 here, an erosional surface happening across these layers that have been moved into that syncline position. After that, we go up to number 6. We have deposition formation happening again, from a fine-grained sandstone to a shale, number 7, to a limestone, 8. Again, fining upwards, indicating marine transgression. And then we move into a coarsening upwards, where we're moving from limestone back to shale, number 9, into a fine-grained sandstone, number 10, indicating a coarsening upwards again, and that would be indicative of a marine regression happening in this area. Then we're going to move over to number 11. We have an angular unconformity happening for numbers 1 through 10, all of these, and that is the tilting of all of these from their original orientation. Looking at the tilt of all of these layers and their associated features relative to the surface, indicating that some force has occurred, some event has occurred to change that original horizontal orientation of these layers, and that's the principle of original horizontality coming back into play. And then we have an erosional surface, number 12 here, moving across all of these tilted layers. And then moving up to number 13, we have the formation of a coarse-grained sandstone, and fining upwards to 14, a fine-grained sandstone. And then we have an igneous intrusion happening, moving across all of these layers and doing some work along those layers. And it's becoming an extrusion here, number 15. And we know that this particular layer is younger than all of these other layers present due to the principle of cross-cutting relationships, indicating that these layers all had to be present before this intrusion and extrusion could cut across them. And then finally, we have a erosional surface happening here, number 16, that cuts across the extrusion, the igneous extrusion here, and then these two layers of sandstone. And so we know that this particular feature is younger than the extrusion here, because it is eroding that particular layer as well. And this also shows the principle of lateral continuity, which states that sedimentary layers are deposited uniformly over a wide geographic distribution. And in this case, you have this disruption here to the layers, but on either side, you can see that the layers are in fact uniform and were at one point in time deposited uniformly through that space. So that's my block diagram sketch. Also, I'm going to show you this quick video of what I did with natural materials to also illustrate this particular block diagram and the relative age dating techniques that can be applied to this kind of illustration, because I work in an experiential environmental education setting, and I wanted to practice using natural materials, mostly different sized pebbles and rocks, to visually show students the layers that are present in this type of situation, and then how to look at it through time and try to figure out how those layers relate to one another in terms of when they were deposited and changed or transformed. So I just played with that a little bit with these materials and that's that for me. Thanks.